Great ranking can still look awful when duplicates flood the page. We'll add SimHash dedup so your first page stops repeating itself. Many search systems return many near duplicates that look different to rankers, but read the same to users. Fixing that improves click diversity and reduces wasted screen space. By the end, you will understand a simple, stable SimHash pipeline in Python that removes near duplicates from a ranked list. I'm Professor Pi, teaching search and IR with simple Python. Search engines and result pages often face a simple pain. The top results can repeat the same idea with slightly different words. Success looks like distinct options across the first page, not multiple copies of the same source. SimHash helps because it builds compact fingerprints that capture document essence. It is fast to compute and cheap to compare, so it works when you have a few thousand or a few 100,000 short titles. It is not perfect for deep semantic paraphrase, but it is excellent for catching near duplicates and boilerplate. At a high level, SimHash turns each document into a small, fixed fingerprint. Similar documents produce fingerprints that differ by only a few bits. That means you can compare fingerprints with a Hamming distance and quickly find near duplicates. The trade-off is simple. Wider fingerprints reduce accidental collisions, but cost more CPU bits to compute. We will build a tiny SERP-style example. You will see tokenization, stable per token hashing, a 64-bit SimHash, pairwise Hamming checks, a threshold filter, and a final rank dedup. This will feel like a full micro pipeline before you scale it up. Now we prepare the tiny result set and clean tokens. This snippet normalizes and tokenizes a tiny set of SERP-style texts. It imports regex for simple lowercase word extraction, so later hashing is stable and predictable. The list docs holds short result titles that include near duplicates by design. The function toke returns alphanumeric tokens for each string, dropping punctuation and case differences that would otherwise create spurious mismatches. The list tokens applies that function across all documents, producing clean inputs for similarity hashing. The printed count confirms our input set is ready for hashing and comparisons. Next, we build deterministic token hashes and the compact fingerprint. This snippet builds a 64-bit SimHash for one document. The helper H uses hashlib.md5 to create a deterministic 64-bit integer per token, avoiding Python's randomized hash. The function SimHash accumulates signed bit votes over 64 positions, pushing bits positive when many token hashes have that bit set and negative otherwise. It then emits a fingerprint by setting bits where the vote is positive. Printing the first document's fingerprint shows the stable, compact signature we'll compare later. Using more bits reduces collisions, but costs a bit more CPU. After computing fingerprints, we will inspect how similar items are. This snippet compares SimHash signatures via Hamming distance to find the closest pair. The function HD computes the bit difference count using XOR and bit count, which is a fast proxy for textual near duplicate detection. The list sigs creates a SimHash for every tokenized document. We build all unique pairs with their distances and sort them, so the top entry is the most similar pair by signature. The printed pair indicates which two results are nearest duplicates, highlighting where your SERP risks looking repetitive. Now we choose a threshold and prune duplicates from a list. This snippet filters near duplicates using a distance threshold for diverse SERPs. The variable tau sets the maximum Hamming distance to consider two signatures duplicates. We scan documents in order, adding an index to keep only if it is not within tau of any already kept item. The check uses HD against previously accepted indices to avoid transitive duplication. Raising tau catches more near duplicates and removes more items. Lowering tau is stricter, keeping more items. The printed indices show which results survive deduplication for a cleaner page. Next, we simulate a simple ranking and apply dedup on the ranked hits. This snippet ranks by a simple token match and applies SimHash-based dedup on the ranked list. The query Q is tokenized and scores counts token overlaps between Q and each document to simulate a basic lexical rank. The list order sorts by score descending, then by index for deterministic ties. We walk the ranked list and keep only items whose SimHash is not within the duplicate threshold of any previously kept item, ensuring diversity near the top. The printed final order shows a tiny baseline where users see distinct options first. Let me add a short mapping to production. In a live system, compute SimHash at ingestion and store the 64-bit fingerprint with the document. At query time, compute the query score and then scan top candidates, applying the Hamming threshold against stored fingerprints. For many documents, you can pre-cluster by prefix bits or use an approximate nearest neighbor on binary vectors. Recap. What it is. SimHash is a compact fingerprint that captures token-level signals of a document. When to use it. Use it when you need fast, near-duplicate detection over short texts like titles or snippets. One caveat. It catches surface and token overlap well, but is weaker on deep paraphrase or semantic rewrite. Next step. Tune the duplicate threshold to trade recall and precision, and try wider fingerprints if you see collisions. If short practical IR helps, subscribe and watch the IR videos.